I was here yesterday and I really enjoyed the presentations. There were a lot of similarities, a lot of things I could recognize, and that is both stimulating from other industries, but also reassuring that in healthcare we're not doing it that bad. So, and I hope you have the same experience. So in this presentation, I will share with you my experience as a medical specialist and as a former lead data science of the digital health department in UMC Utrecht. And UMC Utrecht is an academic center in the Netherlands and not really different from other academic centers. Actually here you see the campus because UMC Utrecht is part of the University of Utrecht. So 13,000 people are working in UMC Utrecht only, and we are providing care, education and research. And as being a partner of UMC, of the Utrecht University, you can imagine that research is really well resourced, a lot of people. And also the AI and the data science and development is very research driven from origin. So if you talk to a lot of professors in our university or university medical center, nothing new, we did it already for 50 years or longer. So, yes, they are doing a lot of research and they are building a lot of models and they're doing a lot of PhD theses and they end up in the draw, actually, very often, and are hardly implemented. And that's where the change needs to be, because we are not researching to build beautiful, beautiful models that are not implemented, but we are doing research to make impact on society. So this presentation of mine is not so much about the most beautiful model, the most perfect model, predictive model, or other AI solution. It's far more actually about organizational change, societal change, and cultural change, which is needed to get things implemented. So let me see if I understand this correctly. Yes. Now I'm going very quickly. I want to go back. Sorry. I have to say that I have nothing to declare and I speak in a personal capacity. All my thoughts are my own opinion. So please be aware of that. And then I want to say something about what is driving healthcare actually, in the Netherlands at least, and probably in all of Western Europe. Like I said in the beginning, the driver of AI is research bias also, because what are we actually studying? Are we studying the population? Who has a clue? Who can say something about that? We are not. We are studying really selected groups, cohorts of patients. So actually what we are seeing in our hospital, very often an elderly patient, very often a lot of comorbidity, 65 or 70 plus, 50% is female. And what are we studying? Male mainly, with only one disease, no comorbidities, probably between, what will it be, 25 and 55, maybe 60. So actually what we have been studying so far in to build our medicine therapies and our approaches on is far from reality in life. So actually a few of the first pioneers in healthcare, they said AI can help us and data science can help us to create really a learning healthcare system, that we are really learning from the data we are collecting in real life. And they wanted to use those data to really learn about the patients who are really in their polyclinics, in their outpatient wards. And so this bias from research, we have to really be aware of that, because it's also affecting our future models at this moment. Then the second thing is, of course, the driver was we get much more data. It's a really data-rich environment. The omics, the genomics we are testing, it's growing, and those data are worthwhile and ready to research. Then we are working digital. Everything is now in an electronic health record. About 20 years ago, it was not in every hospital, but now everything is in an electronic health record, so digital available data. And then what you have seen, so this was the first, these were the first drivers, but what you now see is that actually some capacity and costs and more business-like drivers are coming up. So the drivers are the increased demand, because in the Netherlands the population is getting elder and more demand, and the demand is increasing. Also the costs, actually the GDPR, the percentage of GDPR we are spending on healthcare is increasing, and in the government and in the Netherlands we say it's not sustainable on the long run. We cannot spend so much money on healthcare only. And also the amount of people who are actually working in healthcare is increasing. And again, that too is not sustainable in the long run, because we cannot afford to have, now we have 15% of the people in the Netherlands working in healthcare, and we cannot afford to let that grow a lot higher, because we need those people also in other industries. So basically these are the trends that are looking at AI and digital transformation as the big promise. And we hope that this promise will be a true solution. But I have to make a short expectation warning that it's not going to be the sole solution of our problems. So healthcare is a horizontal technology. AI is a horizontal technology, and you probably understand that it is transforming healthcare in every segment. It's transforming our research, it's transforming our education, our businesses, and our care and cure. And I have enlisted some examples, and there are only very few examples in each segment. So this is transforming, and as we are, yesterday we spoke about strategy, and I realized that putting a strategy on this kind of transformation is quite difficult, because everybody, 13,000 people in our organization are actually thinking about AI and how to use AI. So that is a challenge. And then if you, so I'm going to focus today, actually, sorry, too quick, I'm going to focus on the care and cure, and mainly on the machine learning and data science and the large language models implementation, clinical decision support. I'm not going to focus on robotics, because their AI is most of the time incorporated in the machines. It's a different kind of innovation. So if we're rethinking the amount of machine learning models which are built by the research groups, then if you look what the FDA in the USA actually has approved to use, then you see a huge difference. And what you see here is that the 77% is actually radiology, and of only 692 devices. And actually, that seems to be a lot, but if you look at the number of publications in PubMed, then we have over 2,000 or even more models published to be very interesting. So who knows why radiology is so much ahead of other solutions? Who has a clue and wants to speak out? And if not, I'm sorry? Data and money. Yeah, they have data, and they were very early digitalized already. So they had they were a front runner in this, and they have their data. It comes from machines, so it's very clear and quality high data. So they could build this AI models to improve and to support their work. And the other thing is that it is actually it is AI which is included in their work processes. So they don't have to change their work processes. It's something they are totally in control in their own setting. So that helps. And actually, if you look at this picture and the 77% of radiology, and you look at, for example, the other 10% in cardiovascular, this is also image recognition mainly. And also pathology is image recognition, neurology. So a lot of those actually is all image recognition. Image recognition is ahead of all other developments. So I will show you some examples of image recognition. This is radiotherapy. So radiotherapy, they have to draw which areas are not to be radiated. Thank you very much. You know, so which areas not to be radiated and which areas they should radiate. But mainly those areas not to be radiated, somebody used to draw manually lines around organs. So you see here a kidney and some other gut structures and some other internal structures of the belly that they had to draw. And actually, the radiotherapy department in our hospital in UMC Utrecht, they built a machine learning, a deep learning algorithm that actually draw those lines. And the people who did it manually normally took 3 hours to do this. And now it took them only 45 minutes. So that's a huge reduction in workload. And the business case was very clear. And then you can say, okay, were they afraid that their work was going to be obsolete? No, because we have such a huge demand. They were actually happy because they could help more people. So here it is a win-win with the user and also with the patient. So this is something we have developed, our radiology department has developed themselves, and they are developing it in collaboration with the provider of the machines who are doing this radiotherapy. And they are actually, this is really co-creation, so because these are software as medical device, the manufacturer of the machines are now actually using this in their middleware and are exploiting this in other hospitals. This is a way of co-creation. Here's another example of image recognition in mammographic screening for breast cancer, which is a huge population screening with millions of women are seen in Europe. And here they are, you can use AI in different settings. And I wanted to point this out, that it is very important that you think about how are you going to use this AI? Are you going to use this AI as an independent reader? Because these mammographs need to be read by 2 radiologists. Normally, are you going to use an AI as an independent reader and replace the radiologist? Or are you going to use it as a triage tool, which is going to categorize all those mammographs which are absolutely there are no deviations on those mammographs. So you can say these are really free of any risk. So the radiologist is only looking at those with a high risk. Or are you going to use it as what you saw earlier, as an augmented intelligence? When the radiologist is looking, then the AI is actually pointing out to areas which could be of higher risk. So this is something, and models are sometimes differently built, so you really have to know what kind of model am I using. And here they have built a model that is used to replace a radiologist, actually. And this is one of the first, after I think already more than a decade of research, one of the first prospective studies from real life. So this is from Sweden data, where they have analyzed the data from real care and looked whether or not the AI could replace one of the radiologists. And then they do a non-inferiority test. They look, is it good enough? Is it equally well as our current standard of therapy or current standard process? And what you see here is actually that the number of, you see, it seems to be a huge difference, but actually both the double reading by two radiologists, this is the first bar, that is the normal standard. What you see here is that if you have a double reading by an AI and one radiologist, actually the number of abnormal interpretation is rising. And if you are only doing it by an AI, the number compared to the standard is decreased. And if you have an AI and 2 radiologists, the number of abnormal interpretations is the highest. So what they're doing then is to have a discrepancy, a consensus discussion. I'm sorry?
Can you just say what double reading my AI means?
Double reading and AI, plus AI. So double reading is 2 radiologists and AI.
Yeah, you've got double reading by AI as well.
Oh, by 1 AI plus a radiologist. So then the double reading is 1 AI, the AI is reading and the radiologist is reading. Yeah, thank you. So you want to have the high detection, but you also don't want to have high recall because that is a burden for people. So there you have to find the balance between detection and not too much recall. So what actually was found was that you could replace a radiologist with by 1 AI reading, and that is a tremendous reduce of workload actually. But actually what they also found that you could replace it by only 1 AI reading, which was also not inferior compared to the standard procedure. And there we have a discussion, because is it ethical to have only AI look at the mammographs? Is that something we can do? Is that something actually, what are the risks in the long term? Who is interpreting? Is the patient actually willing to have AI-only procedures? So these are things we have to discuss. And at this point, they are only willing actually to replace 1 radiologist by AI. So other examples of image recognition. Pathology yesterday was spoken about also. Cancer detection, probably you have known about the apps which you can use, which are looking at melanoma. They are not working very perfectly, I have to admit. They are very often saying, please go to your GP, and that is not actually a very impactful outcome. Caries detection at the dentist, and also in endoscopy for adenoma detection, they use image recognition. And there are many more examples on the way. Let's go to some other fields. Sepsis prediction. This is a machine learning model. These are machine learning models. They are looking at data in the electronic health record, laboratory data, or maybe sometimes text mining data, patient-specific data from patients like age or comorbidity, things like that. And sepsis is worldwide is a very big disease. 50 million people are suffering from it. 11 million yearly are dying from it worldwide. So actually this is a big research area. And people are looking for solutions to improve those outcomes. And solutions are very often looked into either new biomarkers, so some kind of chemical substance in your blood, and also in risk assessments, ordinary risk assessment. They just have some expert rules that you just a checklist, is this, yeah. Okay, then there's a high risk, and we should think about sepsis care. And now they are also using these AI models. And the action actually, because you want to build AI models that are leading to action, and the action actually is that you are going to prescribe antibiotics and you're going to do fluid resuscitation. And the sooner you are in a sepsis, the better the outcomes are. So the timeliness of the action is actually very crucial in the outcome. Sepsis models you can build in 2 ways. You can either build a model that is predicting sepsis risk at a certain time point. So when the patient comes to the emergency room, then you can say, what is the risk of this patient at this moment in this setting to get a sepsis in short time. But you can also build sepsis models actually as a forecast, which is moving along with the patient when he is in the hospital, on the ward or on the ICU. And then it's just moving along with the patient based on the data which are coming back and forth from the electronic health record. So these are 2 models again, and it's very important that you are thinking about how am I going to use, what is the question, what is the problem, and how am I going to build a model that is solving this problem. So this is a study actually from this year where they have shown that prediction model, which is a model which is predicting sepsis at the emergency room, is actually very powerful to improve the mortality and the morbidity of patients in this hospital. And they did it actually to alarm nurses. Okay, this patient in this setting has a high risk of sepsis, and you could see that the nurse and the doctor are discussing the risk and then decide whether or not to start sepsis treatment or sepsis bundle care. And it had an impact on mortality. But interestingly, they studied it in two hospitals. And one hospital, the impact was very clear. In the other hospital, there was no impact at all. So heterogeneity between hospitals actually is very much affecting the outcomes of your model. And that is something we do have to be aware of all the time. I'm sorry, I did something which I should not have done, like this, yes. We have built in our hospital a similar warning for the neonatal intensive care unit. And we had lots of discussions actually with the clinicians about alarms, because clinicians don't want to be alarmed continuously. So we had discussion about how long are we going to, if a patient has an alarm above a certain threshold and you have said it's no sepsis, how long are we going to silence the alarm? And how high are we going to set the thresholds? All those kind of discussions you have to make with the people who are actually using it. And this is now running in a silent mode, which is very often the first stage of validation, to run it in a silent mode to see how it is working. And silent modes can be sometimes need to be run for half a year or sometimes even a year because of the number of patients needed. Again, I should not touch it. So this is the architecture behind it, and actually this was quite a hurdle in our setting, because the IT architect in the hospital is not ready actually to deploy AI in real life, and so we had to wait, and they had to build a lot of structures which were not there yet, that was. And we are still very happy that we achieved this. And actually, I think within the Netherlands, this is now running silently in real time with a delay of only 10 to 15 minutes. It's predicted. And actually, that is in the Netherlands still quite an achievement. So in the hospitals, in the healthcare in general, our architecture, ICT architecture is not really ready, AI ready, to have AI models running in real time. And then, like I said, in the example on the ER sepsis model, there was this difference between hospitals, and this is really a big failure of an electronic health record company, Epic, which is one of the biggest ones in the USA. And they built a model also, and this was this other model, kind of model where you predict during the patient admittance, when the patient is in the hospital, you predict whether or not the risk of sepsis is increasing. And they built this model and just put it into their electronic health record, and then they sold their electronic health record to all those hospitals, and hospitals just got the model and they used it. And and everybody was happy until some hospitals said, well, we have to validate it. And we have to look whether or not this model is actually working in our hospital. And what they found out that the model actually, like it was presented, and the precision and the accuracy as it was presented in the research setting, was completely lost actually in other hospitals. So heterogeneity between sites is very important, and external validation of models is really needed if you want to scale up models across hospitals or across healthcare organizations. So actually, the system was not even sometimes better than the original standard care, which were these checklists where they had, where they just checked whether or not a patient had certain criteria. And the system also was not it was not in time, so it predicted actually a high risk when the clinician already knew that this patient was going to have was experiencing a high risk for sepsis. So timeliness, heterogeneity is all important, and this is also because unfortunately healthcare data, real life, are really, really messy. And there are a lot of differences in definitions in the way we are defining parameters in our electronic health record. So it's not easy actually to build a model here and then just transport it to another site. This is a big problem also for commercial companies because they have to train and validate their models in every other site. So I'm going to skip this because of time. It's another model, but on another topic. So then Gen AI last year just jumped in. We were working on text mining already with complication and adverse events, looking for that. But then Gen AI comes in, and here this is already stirring up the business again. And a lot of the electronic health records are now co-creating or are collaborating with Gen AI providers. In particular, again, Epic and Microsoft are expanding their collaboration and including OpenAI or Gen AI abilities into their electronic health record. But then again, we don't know how these models are built. We don't know how they are used and how they are transformed. So actually, in healthcare, we are very skeptical whether or not this is going to be a solution, and we should be very critical to really understand what the impact of this is on people. So, of course, Gen AI, a lot of impact. We expect that there's a lot of administrative burden reduction, summarizing records, automating letters, speech-to-text to report, etc. So, but are we now optimizing suboptimal processes? Is that the focus we're running into? Or are we now losing focus on really patient-centric innovation? And are we just optimizing our imperfect businesses? And the other thing is that we need to really think about the environmental impact of Gen AI, because a question in Gen AI is actually has a far larger footprint than a question when I ask it my colleague on in the next door. And yesterday somebody said it's for free. No, it's not for free. It has a cost, and it has a big cost. So complexity in healthcare is actually increasing when there's decision support and when it's going to be a clinical decision support. And then we are discussing about software as a medical device. And then regulation comes around, like the medical device regulation, the GDPR, and of course all the other regulations. And also we have to understand that that patients are not just within our entity and just within our organization. They are traveling to a healthcare system. They are traveling from the GP to the hospital, back to the GP again. And actually, if you are looking into the further future, you have to think about how are we going to use AI models outside of our own organizational entities, and how is AI governance going to be when we are using AI models that are using data from the GP practice, but are actually reporting the outcome at a whole other organization. These kind of things we have no answers, and we should think about it. Yesterday somebody already says it takes a multidisciplinary team. Yes, a village. It is a village actually, and it is growing. And I see Pepe getting uneasy, so I have to speed up even larger. So this is our organization maturation. We have looked for pioneers in our organization, and then slowly developed actually more and more AI solutions. We have built a centralized AI hub to leverage those pioneers, but also to work on the AI governance and the network and to learn from each other. And in the end, actually, the vision is that you have a centralized expert group, which is actually supporting the decentral execution teams. Collaborate is actually the key factor. Something about whether or not you should invest in IT. This is, I think, a very interesting picture because I find it very recognizable also in our setting. That actually the most important thing is actually that you should invest in innovation management rather than IT. If you look at companies with a strong transformation management, they are more profitable than companies that only invest in IT. So the innovation management is actually one of the crucial parts of your digital transformation. And actually innovation management, it's sometimes strange, but in a research environment, innovation management is also not the strongest competent. So innovation management, explore and exploit. I think this is something you know really a lot about, and we have been doing this and learn by doing and also stop. And we have talked a lot about this yesterday also about the innovation funnel. In the Netherlands, we have had a governmental program which helps healthcare organizations to really build and to get more competent in AI development. And this, I think, is one of the most beautiful instruments which came out of it, which is about value-driven innovation. And it is really using the innovation funnel and gated go, no-go decisions, which has to be really explicit, where you're going further. Because AI model is only a small building block. I'm always finished, Pepe. AI model is only a small building block of an AI application, actually, and that's something we very often forget, that it needs a whole configuration around it before it actually works. So actually, I say the AI model itself is only the easy part to build. And even if you look at this, because this is still very technical, but if you go further, then you will see that this is actually built into a social environment, social technical environment. And if you're looking at how we are thinking about AI governance, very often we are thinking about governance within the model, privacy by design, safety by design, a lot of things we think we can solve on a technical level, but actually a lot of the things we need to be thinking about is whether or not our users are aware, are they trained, do they know what they're doing, can they use it, the risks which are related to misinterpretation, the risks which are related to misuse. So actually the social technical contact and a system approach for safety is really urgently needed. And risks cannot be captured alone at the level of the model. So collaborate. We have built, when I was in the UMC Utrecht, I've built collaborations with a lot of hospitals in the Netherlands, and we are meeting at a regular level to discuss our progress and our hurdles. And I really recommend you to do the same. And then finally, my last slide, trustworthy AI implementation requires actually a lot. Multidisciplinary expertise and governance and infrastructures supporting digital innovation, internal and external collaboration and education of stakeholders. And it was not without a lot of help from other people. Thank you.